Very good afternoon, all of you. Welcome to the physics class. And from today, we are going to start with a new lesson, which is known as motion in a plane. For class 11th, as per CBSE syllabus, we are sharing this video on behalf of Ambition Vedic classes for education purposes only. So, in previous classes, maybe in 8th standard and 10th standard, we have studied little bit of basics of what are scalar and what is a vector. So, today in today's class, we are going to discuss these basics and then we'll move forward to how these basic scalar and vector quantities are useful for understanding the motion or quantifying a motion in a plane. Okay, so plane is nothing but a wall. You can consider it as a wall. So one side of a wall is one plane, then floor is second plane, and the ceiling or the top of the house is basically a third plane. So let's start the discussion or the lesson with the basics. So in previous classes we have studied what is a physical quantity. So we'll quickly revise what is a physical quantity. Physical quantity means anything that can be measured, okay, anything that can be counted, anything that can be calculated. Okay, so any such thing which can be calculated, counted, or its amount can be determined is known as a physical quantity. Previously we have seen that physical quantities, they are of two types. One is called a fundamental physical quantity and another is known as derived physical quantity, right? So fundamental physical quantities, they do not depend on anyone to give them some information, but derived physical quantity, they collect information by multiplication or division using fundamental physical quantity, and then we end up getting the value or the magnitude of derived physical quantity. So a physical quantity can be classified as a fundamental physical quantity or a derived physical quantity, right? That is one way of quantifying a physical quantity, right? There are many ways in which we can classify these physical quantities, and these ways depend on our usage, how we are trying to use this physical quantity in understanding the physical laws or physics that decides the method of classification. So one way of classification we have seen, a fundamental physical quantity and derived physical quantity. The second way of quantifying it as, so in second method in which we classify a physical quantity is nothing but a scalar quantity and a vector quantity. Okay, so number one, it is a scalar quantity. A physical quantity can be called as a scalar quantity, or a physical quantity can be called as a vector quantity. So first of all, what is a scalar quantity? A physical quantity which has magnitude and no direction. Okay, such physical quantities are known as a scalar quantity. So physical quantities which require only magnitude, that means they have only value, and the value of the physical quantity is enough to completely explain the quantity, then we call it as a scalar quantity. And remember that a scalar quantity does not require direction. However, when we talk of a vector quantity, it's another type of a physical quantity in which direction is very very important. So for example, if we are talking about a force, okay, and we are moving a chair from one point to another point in a house, but if we apply force on a chair in the wrong direction, okay, the chair will not go to the point where we have earlier decided or where we wanted to. Okay, so that is what is vector quantity, a physical quantity which requires both magnitude. So we should have to apply a force, but in certain direction, then only the work will be done or the work will be performed. So a physical quantity which has only magnitude alone and it does not require direction is known as a scalar quantity. A physical quantity which requires both magnitude and as well as direction in order to completely do the useful work, or the work or what we want it to perform as desired. So that is what is known as a vector quantity. Then in detail, there are certain properties that a scalar quantity has. Okay, so we will look at it one by one. Number one, a physical quantity, as we know, which can be completely described by its magnitude alone. Only value is sufficient to describe or explain the physical quantity, and is known as a scalar quantity. So we have seen that a scalar quantity basically has only magnitude and it does not require direction. Fine. Then a scalar quantity, because the quantity is scalar, it has only magnitude. So any scalar quantity can have a value 0. It can also be positive, but a scalar quantity can never be negative. Very, very important. So a scalar quantity can never have a value in minus. It will always be in plus. Either it will be 0 or it will be in plus or positive. Okay, so a scalar quantity can have a value of 0. For example, speed. If the vehicle is not moving, if the vehicle is at rest, then the speed of the vehicle is 0. If the vehicle starts moving, then the speed of the vehicle will be positive, but the vehicle will never show speed which is in negative. Very, very important, right? Then there are some examples, as you can see, how to write down a scalar quantity. So a scalar quantity, for example, first example is mass. So as mass is basically a scalar quantity because it is always positive. As you can see, the scalar quantity is always expressed with a value, magnitude, and its unit. Okay, there is no necessary direction. See, whenever we go to a shop, we talk of 50 kg, 100 kg rice. We never talk of minus 20 kg rice. So minus 20 means basically you went to a shop and we are giving the shopkeeper 20 kg, which is not possible. Fine. So the mass basically is a scalar quantity because the negative value of mass will we will never see, we will never have. Then distance again. Distance is again a scalar quantity. As you can see, it will have a magnitude or value and then followed with a unit. This is how scalar quantities are basically written. It will have a value and then we have a unit. So distance is again a scalar quantity. How come a distance is a scalar quantity? So let's take an example. For example, let's say we are standing at one spot and then we are trying to move on the right hand side. So if we have moved 2 steps to the right hand side, that means the distance traveled by the person is equal to 2 steps plus 2 steps. Okay, but let's say if we are standing at the same spot and we try to move on the left hand side, then again if the person moves 2 steps, the distance traveled by the person is again plus 2, right? So in real life basically we don't have anything called negative. Okay, everything that is in real, in our real life we are using it at present, so then it will always have a positive value, no negative value. Okay, then third very good example is time. Whenever we check a time, time is 15 minutes, 60 minutes, maybe 1 hour, 3 hour, 5 hours, but we never say time is minus 5 hours. Okay, because we can't, the clock will never show us minus 5 value. Clock always shows some number which is positive. So time is also a scalar quantity. And number 3, that is temperature. So temperature again, when using thermometer, sometimes we measure negative value, but in general temperature is considered to be as a scalar quantity and it will always have value in plus.